So guys, in this video we will be seeing about the data types. So data types are normal variables which specifically hold some specific data. The first data type we are going to see is int a is equals to say 5. Now this a is a variable. A variable generally is a memory region which holds some data. I will show you that later. Just for now, think that a is a variable like a area that stores the value 5. The declaration is like this: integer. You need to specify the what type of data this variable should hold. In our case, this is integer and a is the variable name. So you can declare like this and you can assign the value like this. So a is equals to 5. So this is a assignment operator. The right side value will be assigned to this left side value. So a is equals to 5. You can also initialize directly here. A is int a is equals to 5. So that is one type of initialization, and this is the integer data type. So the next data type is character type. Say name is equals to a. So this character data type holds one character, that means 1 byte of character, that means a single character. You can see this name holds a. This is the character type, and the next one we are going to see is float. So these floating point variables holds the type like fractional values 2.3. This integer takes 4 bytes of space. If you declare 5 variables, it will take 4 into 5 20 bytes. So each variable takes 4 bytes of value, 4 bytes of space. So if you declare 10 variables like this with the integer, then the total memory for these integer variables is 4 into 10, that is 40. In the character it will take 1 byte. In the floating point it will take 4 bytes. So this, if you want more precision and accuracy, you can go for double d is equals to, you can say 22 by 7. So you can get some more accuracy. So this double is similar to float, but this double is used for exponential or so many long decimal point values. So this will occupy the 8 bytes. The float will occupy 4 bytes and double will occupy 8 bytes. And the next one I want to say is Boolean. So Boolean data type is very important when we are writing some conditions. So this Boolean data type takes only two values, either true or false. True and bool. I have declared the two variables. One have the value true and another one is false. Now these are the normal data types which we will be using in the normal programs. And you can also specify the negative value. You can say minus, it will be negative. So those negative values are called signed variables. If you put the integer, negative integer, that is signed integer, and signed float, signed double, etc. So now you can also output the value of the variables like std cout. So let me print the two variables just to see. Now you can see hello world 5a. Okay, that's fine. Okay, now what I want to do is I want to put the breakpoint, and I want to show you how these variables are stored in the program's memory during the runtime. So you can click on this gray space to set the breakpoint at this line after all the variables have been initialized. Now run this local Windows debugger. So you can see the instruction pointer is showing this line. That means all these instructions have been executed successfully. Now what you want to do is click on debug Windows and click on memory 1. Now here you can see the program's memory. Now the integer variable name is a. All you can do is you can say ampersand a. So if you type ampersand a and hit enter, it will take you to the address of this variable. So each variable contains the address, and that address holds the value of this 5. Okay, so this variable is this memory region, and which holds 4 bytes of data that contains 5. So this is 1 byte, this is 1 byte, this is 1 byte, and this is 1 byte. You can see 05000000. So you can see, you can think this as a 50 500,000, but it's not. It's in the Little Indian byte order. That means each byte is reversed, and if you reverse from right to left, you can get 00000005. That means it's a normal 5. So in this case, a variable holds this memory region, these 4 bytes, and it contains the value 5. In the same way, if you say ampersand name and hit enter, you can see this is the 41, which holds only 1 byte. So this 41 in the ASCII table, if you can see the decimal value, the hexadecimal value is 41 for this ASCII character capital A. You can see here, whenever I hover the mouse onto this, it shows the value in hexadecimal 41. Now if you say ampersand B, now you can see the value is much more different, right? So you can consider these 4 bytes, and the value 2.3 is nowhere. Okay, there is some theory on how computer stores the floating and double point values. So I will put the link in the description. You can go to this website. So I will explain briefly. So the floating point number is 4 byte 32 bit, and first bit is stored for the sign. So that is, if the negative number, the MSB bit is set to 1, otherwise 0, and the next 8 bits are set for exponent part, and the next 23 bit are set for significant part. So what are these parts? If you can see here, floating point is converted into binary, in this case 10.75, and then it is normalized so that it will take the form like this: 1.01011 into 2 power 3. Here 3 is the number of places the dot has been shifted to left. So this is the form. We need to get the number to this form: 1 dot significant bit into 2 power exponent. So this is the normalized form. After that, we need to add some bias to the exponent. So actually those 8 bits, you have the bias already 137, and this exponent is added: 127 plus 3, 130. So if you take in 32 bits, first bit is set as a 0 for positive number, and the next 8 bits are set for this 130 in binary form, this one, these 8 bits. You can see this is the exponent, and after that you can write this 01011 01011, and remaining bits are 0. Now you will get the 10.75. So that's how this floating and double point values will store. Double point, it's almost similar, but the length of the bits increases. So if you have time, you can read this. Now if I say ampersand is alive, now you can see here Boolean value also takes 1 byte, that is only actually 1 bit, either 0 or 1. So you can see 1. So generally the computers does not understand whether you are saying true or false. So the true bit is set as something value, and is a false value is set to be 0, and the true value is set to be 1. If I say is dead, you can see the value is 0. That means the false has been represented by 0, and the true has been represented by 1. But generally what computers accept is, computers accept the false as 0 and anything other than 0 as true. So you will see that in the conditional statements in the future videos, instead of 0 we pass, instead of 1 we pass any other than 0, then the loop executes, because the computers accept anything other than 0 as true. So these are the main data types that you will use in the C++ programs. So that's all for this video.